According to Santa Monica College of 2021, gravimetric analysis is a quantitative method of determining the accurate amount of a chemical substance by selective precipitation from an aqueous solution, whereby the analyte is chemically converted to a product. There are 4 types of gravimetric analysis, which are the precipitation method, volatilization method, electrogravimetry, and thermogravimetry. In this presentation, we will focus on the volatilization method and gravimetric method in relation to the moisture content in chocolate cookies. Volatilization is a core process in developing the aroma, flavor, and texture of a chocolate cookie. The process of baking causes certain compounds of the chocolate cookie batter to evaporate, including aroma producing volatile compounds or aroma VOCs such as vanillin, diacetyl, furanol, pyrazines, theobromine, as well as water vapor. The evaporated water causes the baked cookie's mass to decrease, which can be used to determine its water loss. However, since the baking process does not only cause water to evaporate from the cookie, but also the aroma VOCs, it is better to not only bake the cookies, but also to perform the oven drying process afterwards to ensure that the loss of mass is actually caused by water and not the aroma VOCs. The objectives of using gravimetric analysis to determine moisture content in chocolate cookies are as follows. Number 1, to accurately measure the moisture content. Determine the percentage of water content present in chocolate cookies by measuring its mass loss upon drying. Number 2, to minimize errors from volatile compounds. Users control drying conditions to account for non-water volatiles such as vanillin or diacetyl. Number 3, to optimize shelf life and stability. The gravimetric analysis tests provide crucial information on how moisture affects fat oxidation and stalling rates, which will help to decide the best storage conditions for long-term storage of cookies.
Now that we know the definitions and the objectives, we may head on to the main part of experimentation, the methodology. Now, this methodology will be split into 4 parts, 4 slides. In this slide, I will introduce you to the materials and apparatus required to perform this experiment. First of all, we will need chocolate cookie samples of uniform size and brand. The sizes need to be the same so that the results we will obtain will not be too far from each other. They will be more or less almost consistent. They will also need to be from the same brand, since different brands of cookies will most definitely make cookies in different ways. Their moisture contents are not going to be the same. As they have different qualities, so do they have different moisture contents, and this could skew the experiment. Next, we will need an analytical balance, with the sensitivity, more or less, as given in the slide. We will also need a drying oven set to 100 to 105 degrees Celsius. It cannot be lower than 100 degrees Celsius because we need the water to reach a boiling point. We need it to evaporate. We need to make sure the samples of chocolate cookies don't end up with much water in them. It can also not be past 105 degrees Celsius because it might accidentally evaporate any other nutrients we do not want to evaporate, such as fats. Next, we will need a desiccator to cool the samples without moisture uptake. A desiccator should be used because it is sealed from the outside world. Moisture does not seep in. We also will need porcelain or metal crucibles or weighing dishes to put the samples in, tongs or gloves to pull the sample out of the oven and into the desiccator, or putting them into the oven in the first place, and a paper and pencil for jotting down necessary information which will help us in our calculations. Here in this slide, I will begin talking about the more important parts of the methodology, which is to say the experimentation part. It will be divided into 3 sections. First of all, we are going to be talking about the preparation steps. Now, these preparation steps are important to make sure the experimentation goes smoothly. First, we must label, preferably with a marker pen, and weigh a clean, dry crucible or weighing dish. The crucible or weighing dish should be clean so that the dirtiness, which might have excess moisture content, does not influence the results in any way, and it should be dry for the same reason, that it may have moisture content that could seriously change the results for the worse. Then we should record this mass of the container. In this, I shall use M1, but if you feel like any other value is easier, you may use that. Next, we place a small cookie sample or a crushed bit of cookie into the container. This will be the sample that will undergo the gravimetric analysis. We then weigh the container with the cookie and record it as the initial mass. Now the initial mass is M2 because it's the second mass we calculate, or should I say tabulate, but point still stands. Weighing this and recording it as the initial mass is important for the following calculations. The next part of the experimentation is going to be the drying process. This is the process where we dry the sample. We evaporate the water so that we can perform the most accurate gravimetric analysis that we can. Now for this step, you must place the container with the cookie into the drying oven. Now this should be done using your tongs or gloves because the oven is definitely going to be hot. It's going to be boiling temperature. Use these items at your disposal to ensure that you end up safe and sound and nice and dry and healthy and able to perform the next step. We should then dry the cookie sample at 105 degrees Celsius for 2 to 4 hours or until a constant mass is obtained. What is meant by that is that there is no further significant or extremely important mass change upon reweighing after additional drying. If there is still a significant mass change, it should go back into the oven. The mass, of course, should also be checked every 30 to 60 minutes, ideally toward the end, to see if it has already stabilized. Perhaps you could cut time with this, perhaps you could cut some corners, but the point stands, if it has stabilized, that means you are doing a good job. And if it has not stabilized, you should leave it in the oven for a longer period of time once more. Finally, we are at the end of the experiment, at the cooling and final weighing step. After the drying, of course, you should transfer the sample immediately to a desiccator to cool it to room temperature. This will prevent water reabsorption from the moisture content in the air. Don't forget, when you want to transfer it, you're going to be holding something that's boiling hot at 105 degrees Celsius, no less. So you're going to have to use those tongs or gloves again. You're going to use your protective equipment again to make sure you don't lose any part of your skin, of your flesh, of your bones, anything. Well, maybe not your bones, but point taken, it's going to be hot, and you're going to suffer if you don't use any protective equipment. And finally, of course, and finally, the step we've all been waiting for. Once it's cool, we have to weigh the container and the dried sample. We have to then record this as the final mass, M3. Now, from M1, M2, and M3, you may be wondering, what do we even do with these values? Well, we use them, of course, to calculate the initial weight of the sample, the final weight of the sample, and the moisture content in the sample. Now, we do this, of course, easily because we weigh the crucible first before we put the sample in. There's going to be a few arithmetic logics in there, but it's nothing hard. It's of course simple mathematics. The values The example values, of course, for this calculation will be presented to you in the next slide, the results slide.
In the voltage method, also known as oven drying, the sample were heated at 105 Celsius until a constant wick was reached. We begin with a 3-cookie sample and measure both the initial and final dry wick. As you can see, the moisture content was calculated using the formula in the slide. For our sample, the result were as sample A is a 13.55%, sample B 13.58%, and sample C 13.98%. This gave us average moisture content of 13.7%, indicating a constant result across the sample. Second, thermogravimetric analysis, known as TGA. TGA gradually heating the cookie sample by continuously regaining its mass. The mass loss observed between 13 Celsius and 125 Celsius was attributed to the evaporation of moisture. According to the graph TGA, the sample's mass dropped from 100% to 85.7% in that temperature range, giving a moisture content of approximately 14.3%. In conclusion, both methods gave closely aligned value with oven drying methods yielding 13.7% and TGA yielding 14.3%. The slight differences is within acceptable limit and maybe due to the greater sensitivity of TGA, because TGA detects the minute mass of changes. The consistency between both methods validate the accuracy of our finding, and we can conclude that chocolate cookies contain approximately 14% moisture.
Using the moisture content percentage formula using the volatilization method, the moisture content in the cookie was calculated. Sample C showed the highest moisture content at 13.98%, followed by sample B, 13.58%, and sample A, 13.55%. The average moisture content across the three samples was 13.70%. In the thermogravimetric analysis or TGA, as the temperature increased to 200 degrees Celsius, the mass of the cookie sample decreased from 100% to 84%, indicating a total moisture loss of 16%. However, after 135 degrees Celsius, the curve flattens, indicating most of the moisture in the chocolate cookie is gone. Based on this data, the moisture content was calculated to be 14.3%. The calculation used 85.7% rather than 84% because 85.7% is the stable mass. Meanwhile, the 84% might be the loss of the volatile compounds like fats or oil.
In this case, we simply can say that both methods are based on the same principle, moisture loss due to heat. Volatilization provides a broad estimate of this moisture loss, whereas thermogravimetry provides more detailed information about the cookie's thermal behavior. In other words, thermogravimetry is like a more refined and sensitive version of the volatilization method. Together, they can provide a comprehensive understanding of how moisture behaves during baking and storage, which is essential for producing chocolate cookies with ideal texture and shelf life. Hence, the volatilization and thermogravimetry techniques are helpful both separately and in combination. Their connection stems from the fact that they both use heating to monitor weight loss. Using both give us as an extensive and in-depth comprehension of chocolate cookie moisture, ensuring that every bite is perfect.
Based on the gravimetric analysis conducted, the following conclusions can be drawn from the objectives. Number 1. Accurate moisture determination. The oven dry method successfully quantified the moisture content in chocolate cookies by measuring its mass loss to provide a reliable percentage of water present. Number 2. Minimize volatile interference. Controlled diagonation of around 105 degrees Celsius ensured minimal interference from non-water volatiles such as vanillin and diacetyl. Number 3. Shelf life and stability optimization. By understanding moisture levels, we can predict storage stability and prevent the issue in stalling in fat condition from ruining our long-term storage plan for the cookies.